So as you all had requested me to take class today instead of Thursday and Friday, I have planned to do so. So today we are going to discuss one of the line balancing algorithms, that is the largest candidate rule. I will be only discussing one problem. You will try to understand that properly. And in the next class, that is tomorrow, I'll discuss the other two algorithms, that is Kilbridge Investor method and the ranked positional weight methods. So today we are only going to discuss the largest candidate rule, and all of you are first of all requested to have a notebook in your hand along with the pen, so that you all can understand what are the steps that need to be followed in order to solve the problems with respect to largest candidate rule. So I'm giving you a minute to just take the book and pen in hand so that you all can solve the problem simultaneously as I teach. Okay, is the screen visible? Please reply. I can't see the chat box at present.
Ma'am, your screen is not visible.
Is the slide visible? Huh?
No. Yeah, now it's presenting.
Is it visible?
Yes.
Okay. Previous different types of algorithms or the methods that we are going to come across. One is the largest candidate rule. Second is the Kilbridge Investor method, and third is the rank position weight method. So these are the algorithms. Why do we use work elements equally or equally at all the stations on the assembly line? So in order to have an equal distribution of the work elements, that work elements are nothing but the total work content that will be separated or that will be divided into smaller elements that are called as the work elements, and these work elements will be equally distributed at all the stations, so that all the workers who are working at the station will get same amount of hours underloaded with work. Okay, so that is the whole purpose of having these line balancing algorithm. Line balancing being a problem in assembly lines, we are going to use this algorithm so that we can allot the work evenly at every station, equally at every station. So in that, this is the first method, that is the largest candidate rule. Um, Basically, all these three methods that we have, these are based on common sense and experimentation rather than any other mathematical optimizations. Okay, so each of these algorithms, all the three algorithms, we are going to assume that the Manning level is going to be one. That is, there is only one worker at a station. That is what is the assumption here. So this is the problem statement. An electrical appliance, a small electrical appliance is to be produced on a single model assembly line. The work content of assembling the product has been reduced to the work element listed in table 15.4. This is the table. The table also lists the time for each element and the precedence order in which they must be performed. The line is to be balanced for an annual demand of 1 lakh units per The line will operate 50 weeks per year. 15.4 are the work elements. Okay, that is, yeah, am I audible?
Yes, ma'am, you're audible.
Okay. You'll please keep replying whenever simply again I'll have to repeat the things. So this is the problem statement and this is the given data. So I request everyone to please copy down this table that is shown here. You need not write the work element description. You can keep that column blank. You'll just write the serial number or the work element number here. You can keep work element description blank, this column. But write down the TK in minutes and must be preceded by the precedence that is shown here. This has to be written correctly. So quickly you'll write down this table in your notebooks. You can just write the heading as largest candidate rule. This problem needs to be solved by largest candidate rule. So at the end you can just um consider one statement here that apply largest candidate rule and solve the following problem. Completed the table. Yes, have you all completed the table?
Yes, ma'am.
Okay. So moving on, largest candidate rule. The very first step in this largest candidate rule is the work elements are arranged in descending order according to their TEK values as in the table. You'll have already noted down the table here. Okay. Now I am going to explain everything with respect to the largest candidate rule. But before you proceed to solving the problems with problem with respect to largest candidate rule, you first need to determine all of these details. Okay. these things that they have asked for. You have to add the number of the theoretical number of workers required. These equations are also already given, and the previous problem was the same problem. It is the telling you all how to find the total work content time or RP or TCTS. All of these things are already discussed. We have already got the solution for all of these things. But as this problem has to be solved with respect to largest candidate rule, things will remain the same, and then you apply largest candidate rule with the following procedure. Okay, so first you will have to determine all of the things that have been told here, and then you have to apply the largest candidate rule. In order to apply the largest candidate rule, this is the table that you have, and you see the TEK values here. All the TEK values in minutes have been listed down here. Okay, based on this TEK value, you have to arrange the complete table time to the lowest. So here you will see 0.7 being the highest. You have to completely rearrange this with respect to the work element number, TEK value, and the precedence. So all of this needs to be rearranged. So that is the first step in largest candidate rule. That is, in this method, work elements are arranged in descending order according to their TEK value. Start rearranging it. Refer to the TEK column and rearrange the TEK values and the corresponding work element number and the precedence, and arrange them in descending order of TEK values. So here is the table work elements which are arranged according to TEK values for the largest candidate rule. So here we have eliminated that work element description column. We have only considered work element, TEK value, and preceded by. So first one in the list TEK was 0.7. So corresponding work element and precedence number has been written down. Likewise, you have next 0.6, 0.4, 0.4, 0.5, 0.4, 0.38, and so on up to 0.1. All the corresponding work element and preceded stations have to be, preceded work elements have to be considered, and you have to write them. So this is the table which shows the first step of largest candidate rule after rearranging the TEK values in their descending order. Any doubts in understanding this first step? Have you all completed this table?
Yes, ma'am.
Okay. After this, we have to draw the precedence diagram. Okay. So Let us see how this precedence diagram needs to be drawn. Is the board visible, the whiteboard? Is the whiteboard visible?
No, ma'am. Your PPT is visible.
Okay. Now,
Yes, ma'am.
is the whiteboard visible? It's visible?
Yes.
Okay. So, as I said, after the first step of rearranging the table with respect to the TEK values, this being the first step in largest candidate rule, the next step is going to be to draw the precedence diagram. Now, how do we proceed with the precedence diagram? So, this is your table. You all have already written down this. Now, whenever we start drawing the precedence diagram, okay, is the screen visible? Can you see the table on the screen? Is it visible?
Yes, visible.
Okay. Just a minute. On the screen or the pen में भी हम आपके पास में आके लग रहा है बारिश लग रही है Just give me a couple of minutes. I'm facing some issue with this pointer. The pen, it isn't writing well. Students, please wait for few minutes. There is some issue with the pen on this whiteboard. So I have asked for another pen, so I'm just waiting. Okay, students, please pay attention now. Am I audible? Are you all there? Anybody there? Can I get a reply?
Yes, ma'am, you are audible.
Okay. With respect to the descending order of PEK values, and after that you have to draw the precedence diagram. Now let's see how to draw this precedence diagram. Okay, for that you'll first need the problem statement. The table that is there should be in front of you. With reference to that, you'll be drawing the precedence diagram. So this is the table that you have. Is this visible? Is the table visible?
Yes, ma'am.
Yes. Okay. So to start with, you can see here, this is the table and this is the work element 1. This work element 1 which says place frame in work holder and clamp. It requires zero point 0.2 minutes to perform the task and this need not be preceded by any other task. You can just get things started with either the first or the second work element. This is what you understand from this table. So to start with, when it comes to precedence diagram, you will have some rough diagrams to be drawn before. Maybe at start, at the very first attempt, you may not get a completely correct precedence diagram. So initially, let us go with the work element 1. You'll just write it as 1. You have to write it as 1, and this has to be written in the form of a node. Right. So I'll write it as 1 here, and you have to close it in a circle. Right. After that, which is the next work element which does not require any prior work to be done. If you can see it from this table, it is the work element 2. It does not require any precedence. So where do you place this 2? Are you going to place it here? Suppose if I'm placing this 2 here. If I'm placing this 2 here, making it as a node and connecting it, that means I am giving this 2 a precedence of 1, which is wrong. Because here the work element 2 does not require any precedence. Can you see here? It does not require any precedence. So instead of placing 2 in front of 1, you can place 2 just below 1. Okay, so here you have work element 1 and 2 which do not require any precedence. There is nothing to be done before. You can start them simultaneously. Next, let us now see what about work element 3. 3 is assemble brackets on frame. That requires a precedence of 1. So you can place 3 in front of 1. Now where do I place it? Can I place 3 here or here, anywhere along this line, anywhere here? Okay. One thing with respect to precedence diagram, you should remember that the precedence diagram starts from left to right. It goes from left to right. There are arrows which will be connecting all these nodes. Nodes indicate the work elements, and the arrows will indicate the direction in which the precedence has to be followed. And when it comes to all these work elements that you see here, just by seeing one work element, you cannot finalize the position where it has to be placed. You have to see with reference to the others also. Like if you can see 3, it requires a precedence of 1. What about 4? 4 also requires a precedence of 1. So can I place 3 here? Instead of placing 3 here, which also requires 4 to be placed, so I'll place 3 here. Okay, so in order to do the task of at work element 3, you have to first complete 1. To represent this with an arrow. Next is, let us see where 4 has to be placed now. Can you see 4 here? 4. Work element 4 needs a precedence of 1 and 2 both. So can I place 4 here such that it can be connected to 1 and 2 both? Okay. So next is, let us see the work element 5. 5 requires a precedence of 2. 2 alone. Okay, it does not require 1 and 2. So here is 2. Can I now place 5? I can place this 5 here. Such that it has a precedence of. So this is the next node 5 that can be placed here such that it has a precedence of 2. Okay, there is some problem with this. I'm using it for the very first time. Okay, are you all there, students? Am I audible?
Yes, ma'am. You are audible.
So once we have placed the work element 5, now let us see about the next work element, that is 6. It needs a precedence of 3, but also 7 and 8 require the precedence of 3, so we'll have to place it accordingly. If suppose I start placing 6 somewhere here, 7 and 8, that will not be right. It has to be placed in a line itself such that you can have the precedence from 3. So let us first try and place 6. 6, can I place it here? 6, I can place it here such that it has this precedence. Next, let me see about 7. 7 also only requires 3. So let me draw 7. So this 7 also needs to be preceded by 3. Next, 8. Where is 8? 8 needs a precedence of 3 and 4 both. So we have 3 and 4 here. I can place 8 here such that I can get a connect with these both. So again, this is 8. It should have a precedence of 3 and 4 both. Right. Next, 9. Work element 9. It needs a precedence of 6, 7, and 8. We have 6, 7, and 8 here. So I can have 9 here. Six, 7, and 8. Okay, now moving to the 10th one. 10th work element requires 5 and 8. So where do we have 5? 5 is here, 8 is here. So as we have 10, we can place it. I cannot place 10 here. I can, but it should have a connect with 5. So I'll place it in such a way that I can have a connect from 5 and 8 conveniently. So I can just place it here like this. So this is this is 10 as it needs a precedence of 5 and 8. We have 5 here and 8 coming from here. Next, 11 needs a precedence of 8 and 9 and 10. So when it is 9 and 10, you have 9 and 10 here. So we can have 11th work element placed in between like this. Last one, 12, it requires a precedence of 11. So here we have 11, 12 is going to be ahead of that. So 12th work element, it requires the precedence of 11th work element. So this is how you can draw the precedence diagram. I will show the same with help of a presentation. I actually wanted to show it with the presentation itself, but in the previous class it was told that the presentation was not clear. But here you just get an idea as to how you can start drawing the precedence diagram. Why you just cannot place things at random, because you have to follow these precedences that have been specified. Those which do not have any precedence have to be placed first, and then you will have to go on arranging with one or two iterations such that you get a proper flow which goes from left to the right side. Is this clear? Yes. Is it clear? Is it clear?
Yes, ma'am.
So now I will show the same with the help of the presentation. So the largest candidate rule, first step is understood. Second step is the precedence diagram. So here you see the first station, the first work element, second work element. Then third, it needs to be presided by one. So that's how you show it here. The fourth has to be presided by one and two both. And the fifth one needs to be presided by two. So this is how you place it. Next, six, it needs to be presided by three. Seven is also presided by three. And eight, it is presided by three and, sorry, let's see. Yeah, 8 is presided by 3 and 4 both. So this is how it is shown. What about 9? 9 needs a precedence of 6, 7 and 8. So 9 is placed right in front of 6, 7 and 8. Of course, this 9 that you see here, it could have been placed anywhere here, anywhere here. Okay, but that will not give a very systematic look. So you're going to try and place all the nodes which have the precedences should be placed quite close to each other. You cannot have arcs and curves moving from one over the other. You have to place it very systematically such that the things, the complete total work content that is there, it will move from left to right. And with all these straight arrows and not any curves or arcs. Okay. So 10. 10 needs to be presided by 8 and 5. So we have 10, which will be presided by 8 and 5. Next 11, it should be presided by 9 and 10. So we have 9 and 10. In between, we can place 11. And finally, 12th, which should be presided by 11. So this is the precedence diagram for the problem specified here. I hope you all have copied down this. I have in this particular slide, all the TEK values are also written on the notes just for reference so that you don't get confused with respect to the TEK values. The TEK values are shown here so that you can refer them and find things to be easy and not complicated as in when you proceed with the problem. This of course, just by seeing one problem, you may not comfortable with this. You will have to solve a couple of problems at least only with respect to precedence diagram. That's when you will be able to draw your own precedence diagram. So the same thing, if you can just sit and try and draw your own precedence diagram, you will come with different iterations. And as and when you proceed drawing these precedence diagrams, you yourself will start realizing that if I draw it in a certain way, it is not going to be right. Things have to go systematically from left to right and in such a way that the precedence that is there has to be shared by all the other downstream stations also. So things have to be planned accordingly. They have to be placed accordingly. So shall I proceed to the next step?
Okay, ma'am.
Shall I proceed to the next step? Huh?
Yes, ma'am.
Yes or no? Okay. So, given this list, the algorithm that is after arranging the table in the descending order with respect to TEK values, the algorithm consists of the following step. Now, this is very important. Understand this properly. You have to assign the elements to the workers at the first workstation by starting at the top of the list and selecting the first element that satisfies precedence requirement and does not cause the total sum of TEK at the station to exceed the allowable TS, that is the service time. When an element is selected for assignment to the station, start back from the top of the list to substitute for subsequent assignments. Okay, maybe not clearly understood here. I will just explain it with the problem itself. So this is the first step. What do they say in the first step is you have to refer to the TK value and you have to And with reference to that, you have to say for station number 1, the service time is 1 minute. If you can refer to the problem that you have solved previously, which is a single model assembly line problem. The TS value that you have obtained is 1 minute, which is also a part of this problem. So TS value, the TE ke sum should not exceed the TS value, is what they are saying here, as in when you go on assigning. So this is the first step. Second step is when no more elements can be assigned without extending TS, then proceed to the next workstation. And third step is repeat step 1 and 2 for many additional stations as necessary until all elements have been assigned. So here I have this thing, but I would like to explain the same with the help of this board. So is the board visible?
Oh, no, ma'am. The board is not visible.
Okay. Now is it visible?
Yes, ma'am.
Okay. So now we have come to the third step. The first step we saw was to arrange all the PEK values in descending order. After that, we have to draw the precedence diagram. And after that, now you have to start assigning the workstations. Are both the tables visible?
Yes, ma'am.
Yes? Okay. So here you already have this table which is shown on the left top corner. Is it visible to all? The work elements arranged according to TEK value for the largest candidate rule. You have written, this is the first step that you all have written, right? This is the first step. You all have it with you in the notebook, I suppose. Yes? Yes or no?
Yes, ma'am.
So with the help of this table which is on the left top corner, we are going to get the solution, which is the table on the right bottom corner. Now how do we do this? You are going to okay. Either it's too sensitive or it does not work only. Fine. Been specified. I just read those steps now for you all. The first thing that we'll do is you are going to draw this table that you see here. This is the table that you need to draw. You can just draw the columns and keep it. The first column having this table, station, that is the number of workstation. This is going to give you the number of workstations that will be required in order to accomplish the complete work content. After that, you write the work elements, then you have TEK table, and then the station time. The station time is nothing but the service time, TS. That is, you refer to TS in order to get the station time. So you'll just write down this column that you can see here, this table with all these columns: station, work element, TEK, and station time, and keep these columns blank. We'll go on filling them as and when we just proceed. So this has to be there for your reference. You already have this table. This was the first step of the solution. Quickly write down the table. So now, the first thing to do here is you are going to refer to this table. So here now, so let us now refer to this TEK values, okay? Okay, I'm having a lot of technical problems here with respect to this whiteboard. Either this pen is very sensitive or it is not at all sensitive. So please excuse me for this. Okay, now if you refer to this TEK column, let us start with okay, so here first you write station 1. Okay, in that station 1, we will go on allotting the work element such that at every station there is going to be almost equal distribution of work elements, and the time at every station is also going to be almost equal. So how do we do that? To start with, you have to first start from the first element that is there in your table. If you consider this work element 3, what is the time that it takes? It is going to be 0.7. Okay, am I audible to you all? Are you all there?
Yes, ma'am, you are audible.
Okay. So here, if you consider this first work element that is shown in the list that you all have written, or the first step of your solution, if you see the TEK value is 0.7, but it needs a precedence of 1. So you cannot proceed with the allocation here because it requires some precedence. Some prior work has to be done. So as we cannot go with this, why is this happening? Okay, I cannot use 3 because it needs a precedence of 1. I cannot use 8 because it needs a precedence of 3 and 4. I cannot use Hmm? Okay. Okay. Okay, there's some problem with this board. I'll better go with the slides only. So when you start allocations, how do you do the assignment of work or allocation of this work element? So you all have already written this column, right? All of you are requested to please have the first step of the solution with you. So let us start with the first step, that is at first station, what will be the work elements that will be assigned? So that depends upon the TEK values and the precedence. I just cannot proceed with the first work element, that is 3, having a TEK value of 0.7 because it requires a precedence of 1. We do not have any precedence, there's no prior work, nothing is done, so you cannot just get started with it. So let us see that work element which does not require any precedence. So we have option of having work element 2 which has a TK value as 0.4, or I can go for work element 1 which has a TK value of 0.2. Both the 0.4 and 0.1, 0.2 are going to be less than the TS value, that is 1. But let us take the maximum of these two, that is the second work element which has TK value 0.4 and does not require any precedence. So this is the first allocation. At station 1, the first work element will be performed, which is going to take 0.4 minutes. After this, you just strike that two work element in your previous step. I said you have to refer to the work element arranged according to TK value for largest candidate rule table. In that, you strike off this allocation, that is 2. Once you strike off that allocation, you go back to the step 1. That is, you start from again, you have to see at work element 3. Can I now place 3? No, because it needs to be having a precedence of 1, and also the TK value is 0.7. If 0.4 and 0.7 are added, it is going to exceed 1 minute, that is the service time. So you cannot exceed the service time. All the work allocations have to be done in such a way that they are within the service time limits, allowable service time. So you now see, if you can proceed down, you will see that the next work element is the fifth work element having a TK value of 0.3, which can be placed here. Likewise, the next one is going to be 1, and then you have 4. If you sum all of these, it is going to be, station time is going to be 1, which will not exceed the service time. So at first workstation, these work elements can be assigned. So this completes the allocation at station 1. Now still you have many other work element allocations pending. So let us start with station 2 now. Station 2, now you are going to, whatever work elements you have already assigned here, those work elements should not be reassigned. The assignment is over. You're just going to cancel off all of these work elements in your table. You only proceed with those which are now remaining. And after every allocation, you have to start from first. You have to start scanning from the first work element and go on till the end in that first step table. So the next thing is, if you consider 3, it requires a precedence of 1. It's already taken care in the first station itself. So that precedence is already over. Next is 6. If you do 0.7 plus 0.11, it is 0.81. Let us again scan from top if you have any other allocation possible. No, it's not possible. The total is going to be 0.81. If you're going for any other allocation, it is either not possible because of the precedence constraints or because of the TEK value. If you sum the TEK value, it should not exceed 1. So any other allocation, if you try to do, it will either exceed TEK value or it will not have the not satisfy the precedence constraint. So at workstation 2, you have only these 2 work elements. At station 3 now, you have the allocation of 8 and 10, summing it to 0.98. Any further allocations are not possible because of precedence constraints or the TK values sum exceeding 1. Likewise, you have the 4th station allocation. Here it is 7 and 9. And then the 5th allocation. So likewise, you can just go on allocating all the work elements to stations. With this table, you can understand that there will be 5 workstations required in order to complete this total work content. So this is how you're going to assign it. After you assign this, you will now refer to the precedence diagram that you all have drawn, and these workstations, like the first workstation is going to have 2, 5, 1 and 4 in one workstation. So all of them are just going to be put in a box and you will just mark those as the workstations. So this is the first figure which is showing the assignment of elements according to the largest candidate rule. And this is the second figure which just shows a simple physical sequence of all the workstations which are having the work elements assigned to them. After you finish this, you have to find what is the line balance efficiency. Line balance efficiency is given by TWC upon W into TS. You know what is the value of TWC? It is 4 minutes. You know what is W. W, how do you know what is W here? Because you have assigned all the work elements, and from the table you can identify that 5 workstations are required. Therefore, the W value is going to be 5 here, and the TS value is known, that is the service time, that is 1. So balance efficiency needs to be computed, and you get the balance efficiency as 80%, and the balance delay will be 20% or 0.20. So this is how you solve the first line balancing algorithm problem, that is largest candidate rule. Because of this technical problem, I could not show you all clearly how these allocations have to be made. I will just try and make one short video about these allocations and I will place it on the classroom, because this whiteboard is not supported me well while explaining you all this. Maybe I was making some mistake, or maybe there's some problem with this whiteboard. I don't know what it is, as I'm using it for the very first time. So I'll just try to make a short video about how this largest candidate rule problem has to be solved, and I will share the same video in the Google Classroom in a couple of days. I just hope that will be helpful for you. Is this enough? Yes, is it okay? At least
Yes,
something
ma'am.
understood today. Okay, fine. Then we'll stop here and we'll meet in tomorrow's class. I will try to explain the other 2 methods in the best possible way I can.